Hi guys. My name is Martin Pham. I'm with the Stein Lab. I was hired to do a bit of web development, software engineering for them, specifically with PGMLab, which is something that I've been working on with Adam and Hossein for the past 3 months, 3.5 months. So I want to show you guys, kind of describe what PGMLab is, why we're doing it at OICR, and the actual the web application I was making. And I realized as I was making the slides that I neglected to mention any of the web technologies in the title of this. So if you guys feel like catfished at the end, hopefully you'll be like, maybe you've learned something else. But carry on. All right. So just introduction to probabilistic graphical models. So its name's pretty obvious, but they express conditional dependencies between stochastic variables as a graph. So this is a graph in the sense of like nodes and edges, not like data visualization. So nodes can represent the random variables, and these can exist. These can have different states and stuff. Edges represent the conditional dependencies of these random variables, and so you could have parent nodes. Parent nodes can imply conditional dependence on the children nodes. So you have there's two main forms of them: Bayesian networks, which is what we work with. Formally, they are directed acyclic graphs, but from what I've seen, we have been working with some cycles, and that's something that PGMLab is working on right now, just to be able to make sure that the methods that we're using still work on cyclic graphs. The other one is the Markov networks, which are undirected graphs. They have the Markov property, which is to say that they are memoryless. And so these random variables have underlying distributions that say for whatever model you're using, you want to know. So this is an example I took when this is an example I stole from my prof actually for one of the classes, and it's a Bayesian network. So each node has holds a joint probability distribution of its parents. So say say I take a reading course when I go back to Waterloo, and my professor and my professor Sonder and I have to have meetings every week. These meetings could be canceled if, say, I was late or he's late, and there's conditional dependency on them by, say, if I'm late, there's a possibility that I overslept or that the university avenue is closed, so it's a bit harder for me to get to campus. Same with Sonder. So say he's late. There's a probability that it's because the university avenue is closed, but you can see that the node of Sonder being late and me oversleeping are not dependent upon each other, but me oversleeping and me being late are obviously is. So with these kinds of graphs, you can ask some pretty interesting questions. So say a meeting is canceled, so we know that. So how likely is it that University Avenue is closed, given some previous evidence that we have? Or we can ask, like, given this history, what's the probability distribution function of, say, me oversleeping? So you can imagine within each of these nodes, you can have a conditional probability table that can accurately describe these events. I didn't want to include it because it would just get huge. So what PGMLab is a C library for machine learning that's meant to be fast and be usable by the layman, pretty much. It was developed by Adam Wright and Hossein Radfar here. And it's supposed to be context agnostic, which is to say that like a graph is a graph is a graph. We can apply them to whatever we want as long as the models work out and they are stochastic variables. Yeah, so we use estimation maximization as well as loopy belief propagation to perform learning and inference over these networks. So loopy belief propagation is just calculating the marginal distributions by summing out observed variables. So like, say you have some given evidence and you want to find the probability of another event happening given this evidence, you just have to sum out all the probabilities of the data that you have already. I remember when I actually took the course, my professor actually made us do these by hand. They were pretty hellish. So you can imagine given a lot of nodes and a lot of connections, the computational complexity can explode. But PGMLab implements some algorithms that obviously make it faster and more efficient to do so. I think, yeah, so I wrote down, if you want to do it naively given a graph, it's on the order of k to the power of n, where n is a number of variables and k is a number of connections. When we exploit conditional independence, you can reduce the complexity down to k to the power of n. You can reduce power to kn. So so far this is just machine learning. Why are we doing it at OICR? The other half of this term I've spent working on PGM Bio, which is basically PGMLab plus Reactome. And Reactome is a database of reaction pathways in human biological processes. So here I think we have 2 curators in our lab. who basically just go over papers and add to this database, annotate it, just expand it. And what we're aiming to do is perform learning inference over these networks, given some data that we already have. So say you have a I think which is we have a process called unwinding of DNA. So say you have DNA, RNA, and proteins, and these can all be represented as nodes that are expressed, downregulated, or upregulated. And then their position in the actual pathways is their biological processes. Say this DNA induces this RNA, and then this RNA will. So yeah, I study math, so the biology side of this is not very well grasped here. But from what I understand, the point of it is for drug targeting of oncogenic factors, which is like, say we know that one node in this pathway happens to be a cancer-driving gene, then we want to downregulate it, but we can't just directly downregulate it. We want to find its parent nodes who it is conditionally dependent upon. So we say we can downregulate those so that it is downregulated downstream. So the actual web application part of this talk. We decided to build it on React, Redux, and Immutable, just because React seems to be the new kid on the block. But it also makes, and I use React on my own, so it's actually quite simple to get into. But you can still do fairly complex things once you add like Redux and stuff like that onto it. So yeah, React is an open source JavaScript library maintained by Facebook, and they open sourced it a couple of years ago, I think. But it's picked up ever since. I think it provides declarative and component-based library. So the declarative part of it makes it a lot simpler to kind of to render data that you have in properties and state that the components have. And the components allow you to reuse components. So say on a Facebook website, you have the comment box. That could be one single React component that they can place wherever they need a comment box to be placed. So React components have input data as immutable properties. So you can pass, it's a lot like HTML tags where you can pass in attributes to them, and these are properties available in the actual class. You can also maintain internal state data. So within a React component, it can change its. You can have callbacks that set its state to something different. Does anyone here work with React? Yeah. Okay. So these are all things you guys already know. But for the people that don't, so Redux is I guess it's the library, but it works. You see React and Redux together a lot, but they don't necessarily pair together like you can use it with Angular, you can use it with vanilla JavaScript, you can use it with Ember, whatever else you really want. But the basic idea is you have a single source of truth, which is your app state, which is the Redux store. When used with React, you can describe UI components as a function of state. So given this Redux store, let's say the React component is defined by these certain states that you pass to it as properties, and these within the actual React component, they define themselves. So action, I'll show you guys. So state updates are emitted in response to actions, and then these components react to this new state in this new state on the Redux store. So within the actual React component, you could have a callback that changes the data in the Redux store, and then that React component will then react to this new state as defined in itself. Yeah. So actions also passes component properties, and you actually have to write action creators that normalize what the React component sends, and then what the React store receives when applying these actions to it. So this is just a quick diagram of the unidirectional flow of data here. So you see the React components is actually the view. Then you emit actions. These are reduced so that they can be applied to the Redux store, and then the Redux store is, with its new state, the React components react to it. I think in July, we realized that the state of the app was getting a bit too large, and we needed to make things a bit more to optimize a bit. And so we decided to add on Immutable.js, and that just provides immutable data structures for JavaScript, so maps, lists, sets, but it also provides a mutative API, which is to say that like you're able to get and set the data like with get and set methods. I think there's three main benefits to using immutable, which is that it's predictable, performant, and trackable. So with predictability with the data, it doesn't change. You can't mutate it, so there's no side effects, and you don't get these kind of you change something in one React component, and because it's mutable, there's a side effect in another React component. So there's none of that misbehavior that you might see if you didn't use it. It's performant, so a lot in the way that React does, like reconciles re-rendering by diffing. You can use hash map trees and vector trees to check things by reference. So say you have data that is changed. You can either check the value for it, which is what you would do with that immutable, I guess, or immutable will check the reference in memory. And so if the value's changed, the reference has changed, and so you know it's changed, so you know you need to re-render. Oh yeah, so obviously if you send these immutable data structures to the Redux store, the application can take advantage of all of these. So on top of this, we decided to use ES6, which was a huge update for the language. I think it released like last year. Yeah. So React components can be defined as ES6 classes, which were introduced, and so within these you have a constructor method. You define static methods, and then you have a render method, which actually outputs what you want the React component to render in HTML. So you can write React components in JSX, which is basically just XML syntax with JavaScript, and I think I'll show you some code after. Also with ES6, basically if you're not using ES6 now, I like really encourage it because it makes developing JavaScript a lot more fun. I think it makes it a lot more. There's more structure to how you will be programming, I think, just because of the different things they've introduced. Say spread operator, you can spread an array or an object out over different variables. There's destructuring assignments, which is nice if you want to pull variables out of an object or something. And then there's let and constant keywords, which let you kind of limit the scope of the actual data that you're working with, which is really nice when you're actually, like, when you're jumping into like code that you didn't write, you kind of better understand what's going on. They also introduced modules, which really helps with keeping everything modular. So this is just an example of what an ES6 React class might look like. So you can export it, and then you have the app, you have the class name, which is app, and then you have your constructor method and you have your render method. And then within the render method, it has to return some kind of markup. Oh, and there's also another cool thing with ES6. You can do string interpolation with string literals, and so there you have the JavaScript variable this props dot not variable. It has this dot props dot name, and that will be interpolated right into the string there. So on the back end of PGMLab, we have Klein, which is a micro framework for Python. It's built on what is it? Verkzoid and Twisted. And if anyone here has worked with Ball or Flask, a lot like that, but it allows you to extend it to asynchronous, to handle asynchronous tasks. And so for us, it handles the actual hosting of the files, routes, posting, so when we actually submit to PGMLab, as well as the big thing here, which is the server-sent events, which is what we use to keep track of the task progress, and which I will show you. Yes, so the second half of the actual presentation. So we use Celery for
server event. You mean push event?
What's that? Oh.
Server send event. Is it like a server is a push action?
Oh yeah. So it's this is actually something that we did not. This was actually one of our last options in terms of when we were figuring out what we wanted to work with. It's in the what's it called? Okay, I'll show you guys actually. Yeah. Oh, the web API. Yeah, sorry. This was something that I did not know existed, and I think it's suited for a lot of people's applications. So say you don't want to go through the trouble of having set up WebSockets or WAMP or something, because the flow of data is straight from your server to the client. It doesn't really necessarily need to interact with it. I think server-side events is something you guys might want to look into, just because of how simple it is to actually set up. Does that answer your question?
Oh, because I first time I heard this term as well.
Oh yeah, okay, yeah. So the actual task handling and execution is done by Celery, which is something written in Python. It's task queuing based on distributed message passing, and actually supports different, like a lot of different message brokers. So RabbitMQ, Redis, Beanstalk, Mongo, DB, CouchDB, a bunch of other things. We use RabbitMQ. And so tasks are executed concurrently on worker nodes using multiprocessing. So you can define how many worker nodes you want to have. By default, it's 2. So you'll see later on that it's at max you'll have 2 running tasks at a time. And you can decide to either execute them asynchronously or synchronously. By default, it is asynchronously. So how these two come together. So what we came up with was to abstract some of the higher level functionality of PGLab to a Python module, because PGMLab is some of it. Sorry, I'm just going to move past that. So Celery tasks are defined as Python functions that then called on this PGMLab module, and then these tasks are asynchronously executed on a post request from the client. So you can upload. We have different data files for different data file formats that are used to be processed by PGMLab, and so what the user sees, they can upload this data, and then it will be sent off to the server and processed. So we also have for the actual progress updates, we have a thread that listens to Celery events and then emits these server sent events that I was just talking about. The React application listens and emits actions to Redux events. So it listens, and when it captures these events, it will emit an action that is then sent to the reducer, that's sent to the Redux store, that then changes the app state to update it. So say, so for this example, it receives an update of a task, and so it'll update that task data in the Redux store. Oh yeah, so let me actually show you. And okay, this was actually, I think we're like, task queuing systems exist already. We're not like really trying to revolutionize everything, but I want to show you guys how simple it is to create something that is reactive and kind of it's not so hard, because going into this, there was a lot of considerations to have, and I think the solution that we have is somewhat elegant, but I'll show you. Oops. Yeah. Actually, I'll show you the code first. So the actual React, the client-side web application part of this. So you can see that you have the imports. You can have different. You could have, so within an ES6 class, which is right here, you can have static methods that are then called. You could equivalently do with arrow functions, but I just wanted to show you guys that you could use static methods for this. You could have. This is the render method that you have in the ES6 React class, and it has to return some kind of markup, and that markup can have access to all the data that you have in your React component. And then so the modularity becomes really nice, because you can work on small things and you just have to compose them up into the actual application. This is the actual task table. So you can see it's only like 66 lines of code with comments and stuff. I think one of the really nice things about using ES6 with React is this section right here. I think this might be because working with Adam a lot, he's doing some stuff in ClojureScript right now, and so I was a bit interested in the functional side of programming. And Immutable.js lets you kind of really play around with that kind of the way of thinking. And you see here, there's a property of all the tasks in the task table class, and then you can just access it by this.prompts, and you can act on it using the different Immutable.js methods here, like value. You turn it into a sequence of values, and then you sort it and you map it to your markup. So it's really nice, because in 3 lines of code we can basically render all the tasks that we have. And then a task button. So here you'll see, where is it? This task button right here. We have a method that which we define in the constructor, where it just sends off a simple request. Here you can do a bit more complex things if you really wanted to. For us, all we really needed to do was just tell the server to start running something. Another nice feature of ES6 actually is that if you have a variable that has the same name as your keyword in an object, you can just throw it right in, and it will just work. And another thing is the arrow functions. So this dot submit job is defined as an arrow function, and it's useful because when using arrow functions, you have access to this keyword. So it's a lot. it makes your code a lot less verbose because you don't have to write the function keyword all the time. I was talking about the Redux store in the Redux store in the React application, and so you define action creators that normalize the input of the React components so that the Redux store can apply so the Redux store knows what to do with them. And so here on update task, we just send an update, and the update is just simple JSON that is sent from the server. And the reducer is what takes an action, applies it to the given state. So here I have one that sets the initial task, which is just to set the task property to just an empty map. And then say we get an update. If it's not in, it'll just update it. And there's more nice things about the Immutable.js because the methods they allow for, like, I tried before when we were developing. Not having Immutable.js, a lot of it was very needlessly verbose, but things like updated and set in are quite nice. Show you the actual Celery tasks. So Celery tasks are just defined as Python functions with the decorator. Task like with this decorator here. For this example, I just wanted it to run for between 5 and 10 seconds, and just so that it's not instant, and we have some actual progress to be seen. The server side is a bit more code, but again, it's only 67 lines of code. It's pretty simple. This here is your the routing for the actual post requests. This here is, what is it? Yeah, this here is for actually hooking onto the client side. And so you saw in the task button here, you have an event stream, and so this hooks into it right there. And yeah, and what I was talking about before with the actual events. So we set up a thread that listens in on the on Celery events. There's a bunch of events actually. Like I think it sends off a pulse like every half second or something. In the Celery documentation, there's the actual different events that you can use to actually catch. And so when it actually catches either a task has received, started, or succeeded, it updates it here. And then that update actually just sends the server side or server sent event here. So yeah, let me actually show you how it works. So here's a button that will send a post request to the server. And we'll just send like a ton. So it's actually, yeah, so it runs between 5 and 10 seconds. And so you can see at most you'll only have 2, but that's just a configuration that you can set in Celery. The nice thing about this is that I feel like it's fairly lightweight, and with React, it plays very well with this kind of, okay, we have an update, how does this affect the state? Okay, this is how we're going to update it in that task data. Yeah, quick doc, that's about it. Yeah. Sorry for the abrupt ending.
Which message broker are you using?
We're using a RabbitMQ just because it seemed to be it's the recommended one, and it just plays nicer.
Did you try any of the other ones?
Yeah, we tried Redux, but we were a bit short on time so we just kept using RabbitMQ. Cool.
Have you guys looked into using any of the Node frameworks for the backend for this instead of using Celery?
Yes. Good that you mentioned Celery as well. One of the biggest issues with this was actually coming up with the thread to listen to the Celery events. There is actually a Node module, and there's an npm module that allows you to abstract some of the Celery functionality to Node. So someone's ported it over. So for I think a week we contemplated switching over, just because the client was giving us some issues on something else. But if that's something that you like it's totally possible to use Node and Celery together as well. You don't necessarily have to leave Celery if you want to work with Node. Yeah. Thanks for mentioning that though. That was one thing that like we were like I think Adam can attest to this. For a good week, we were very tempted just to kind of rewrite everything in Node because some of the Python stuff would not work well with PGMLab and stuff like that. But it's been resolved since. Yeah. Any other questions?
I guess my question would be, what's your opinion on those server-side events? Was it worth doing instead of just like a polling?
Yeah, I think because we wanted to be as like reactive as possible, we didn't want to have to like long poll or anything like that, and so it fit well with the way of thinking that Adam and I were going through, where data is unidirectional and you send it off to the server tells you that this is the update. It's not necessarily a two-way communication. I think it's also useful for, like I said, very simple one-way updates. All you need to do is kind of JSON stringify the data that you want and send it over. So I think going forward, I will probably be looking for places where it might be more useful than more complex implementations of communicating between server side and client side. Yeah, I'm for it.
Yeah, one reason why we did it this way was because when you do inference, we can do it on the web page where our visualization, so we draw the graph out and you can see the impacts on different nodes. When you do inference, it comes back almost instantaneously, but when we do learning, it could take 3 or 4 days or a month. We don't know. So if you go back to the website, it would be good to be able to get a fresh start at it and not have, if you're long polling for a month, that's not proper. So yeah, it could just send you back the state of it. So I think when you first go to our website, then it will go, correct me if I'm wrong, it will go and grab you the full current state of everything because we have a database keeping track of that, and then it will send you updates as need be. So
yeah, pretty much. It's the runtime of some of the PGMLab processing is what kind of is the motivation of why we use server-side events.
So if you started a long job and then like left, like turned off your browser and came back, how do you connect again? Like,
oh yeah, so
or is it still like?
So with this, I also like with PGMLab, we also have some simple WAMP components that actually allow us to do like authentication on the server, and because we have to have user sign in and stuff like that. So when they actually log back in or something, it'll actually send you the most recent data, and then you'll keep getting updates from that. And so we didn't want to have to like Adam said, we didn't want to have to like long pull for months or something. Yeah. Does that answer your question? Okay, cool.
yeah, we also, because we implemented the users, we use like just a Google login. Then you only see a task list that you created. So like when we go put this on the internet, you don't see everyone's tasks and it gets sent back. And then within one of those rows, you'll have a download button to get your results. And then it would send off a post request to get back like a zip file of all your results. And that's, so for PGMLab itself, that's how simple it is. And then for PGMLab Bio, we've added a lot more things in, visualizations and all that. So it's more abstracted away from the user, but it's the exact same thing where there's somehow we'll put in it like this back end if they really wanted to see this queue of jobs that could be going for a few days, and then once it's ready they could go use it. So yeah, you'd want them to be able to log in when they get home or when they're here and have it be the same data. So I think yeah, just to make sure it doesn't get out of sync, I guess is the reason.
Yeah. Did you ask me something? Oh, sorry.
So I actually have another follow-up question. This is more just a technical front-end question, but when you do your post to download those big files, are you just doing an AJAX call and then returning all the data in the AJAX response and then like doing a browser download, or do you open up like a new frame?
So for actual PGMLab and PGM Bio, with what Adam said, we have the Google login, and so when the response back to that gives you the most recent data over WAMP, so like over WebSockets, and then from there you just get all the updates. So it's not like there's no
But I mean, when you press the download button, that
Yeah.
Adam's saying.
oh, download button. Oh no, that's just so what we have right now is we want to keep it simple. So right now it's just a file hosted on the server. Yeah. Because it comes in like we decided to have it downloaded as a zip package, and so we just wanted to zip it and then give them the address for it, and they just have to A-link download it. Yeah. Cool.
Thank you.
Yeah. Oh, yeah. So I studied scientific computation. So if anyone noticed any glaring inconsistencies with what I was talking about, feel free to call me out and call me a liar. But correct me, please.